right?
Good morning. Not morning, really, but it's funny to say that. Good morning. Um, it's hot. I think it's like hot everywhere in the world right now or something. So, if you're going outside, make sure that you're wearing sunscreen. If, it's under direct sunlight, make sure that you're not wearing too much, I guess, but you're still covered up. Don't wear dark clothing, right? Doesn't that, um, like, attract... How do you say this? Wearing dark clothing gets hotter, right? Because the black colors, or whatever, the darker colors absorb more sunlight. Somehow. Or something like that. So do that. Make sure you got enough shade. Make sure you got enough water. Stay indoors if you can, I guess. Where it's air conditioned. Where you're lucky to live somewhere where there is air conditioning. Yeah, that's my tip for the day. Maybe I gotta switch to, and I haven't opened up this part of it. These are the things that go on the controllers or something. And then you wrap it around your wrist. So that if you, like, do things with the motion controls, you don't accidentally throw it into the TV or something. But maybe we'll play, I don't know, I don't have a capture card to do, like, Switch games, or Switch 2 games. Or both. I don't have that to do it on stream. But maybe I could get, like, a HDMI splitter or something? I don't know. I'd have to research it. But that would be interesting to play, like, Mario Kart on stream or something. Maybe one day we'll have enough viewers that we can all play Mario Kart. Or some other party game. Mario Party, I'm, like, undefeated, so... I don't know. But, by the time we do play Mario Party, if that all does follow through, I'll be washed up. I won't be Mario Party Master anymore. But in the meantime, we are doing programming. Hopefully it'll pay off one day. So, on today's stream, we'll be continuing doing this like bounding box, or not box, but bounding volume hierarchy thingamajig. Following along with this video here. We're about like right here. Last stream we got this part of it done. I don't know if I can seek through this. Like right here, we kind of have this kind of visualization last stream, where the box here like grows as you add more and more of these vertices into the box. And this is like a point cloud of this mesh, and we have something similar. I can even bring it up. What did I call it? Simple, I think? No, I don't remember what I called this. Single. Yeah. Broken seems. Oops. Oh, maybe the camera. Yeah, it's the camera. But yeah, ours kind of does the same thing, but ours does the, let me fix the camera real quick. Kind of does the same kind of thing, but does it, like, per vertex. There's, in the video, if you go and watch it, that little visualization, it adds, like, multiple vertices at once. But ours is in the same idea. You just expand this box. You know, now it's expanding by this little seed in the avocado. And it just replays that. So we did this last stream, but the next step in this video, and my idea is just to follow along with it. And every time we see like he's like really good about creating like visualizations for these things. Like here we might even do this 2D thing where he talks about how to make your data GPU friendly. So it's kind of a long video, and probably do like a bunch of streams just following this guy as a guide, I guess. And we'll see where we end up in the end. I have watched this before, but it's been quite a while. And, you know, I probably watched it when I was like half asleep, getting ready to go to bed or something. So, but I think it has everything we need in it to do bounding volume hierarchy. I should probably check, but I'm pretty confident that we can get, or at least, you know, I can get what I want out of this video. The whole idea is that we'll be making, I don't know if it'll still be relevant by then, but we'll be making a bounding volume hierarchy so that we can paint on meshes. We'll make like a triangle painter. In the same idea as they do in like Mecha Chameleon, that popular game right now. And if you don't know about this game you try to hide in the scenery, and you paint yourself so that you blend in, and then people try to find you. I think everybody's probably seen this game by now, but it would be cool to like show how would you create this in 3JS, the ability to paint on the model. And you can imagine, like, you have to kind of track where the pointer is at, and you cast a ray from the pointer into the scene, and you see if you collide with this little mesh here, and then wherever you're colliding that, then you're going to change the color of those triangles there, either through like vertex coloring, or maybe you're painting on a texture, and then you're using that textures as a like UV map over the mesh or something. So I haven't thought about which way would be easier, or simpler, or more interesting, but we'll get there eventually. But today we'll be doing this visualization here, which before we do that, we need to create some kind of structure that we can It'll be like a tree structure where we can kind of what do you do with trees? Where you can do tree traversal. That's pretty common. And I'm gonna assume like people know what a tree is and a graph is in like computer science language and stuff. But in this case, you've got two. You got a node. Where's my Scaladrol? So at the very top, you have your mesh. And what we're going to do is split up its triangles into two boxes. So each of these will have, you know, some... Presumably it'll have like half of the triangles. Maybe not necessarily half. But it'll split it up into two sections, into two boxes. And then, you know, you have the other half over here. It doesn't necessarily have to be a half, depending on how you split up your triangles. But for our case, at least, it will always be two children, a left and a right. And then you can go further and then split this in half as well. Again, it doesn't really have to be a half, but you keep splitting until you reach some like, okay, I'm good. Like here, you know, this is like a depth of, I can't remember if it's 2 or 3, but you keep going until you reach some like stopping condition. And I think we have a good one. I have a good one in mind that will kind of help us visualize this as well. But eventually you'll reach a point where these are null, meaning like there's no more to go through. So each of these will be leaves and they'll all be null or whatever, right? And then to kind of check, like as you cast a ray into the scene, you know, you need to track which boxes. So these are going to be like boxes around parts of the mesh and stuff. And you know that if you the only way you can hit like a certain triangle is if you hit one of the boxes above it. So this is kind of like, you know, if I hit one of these boxes, I don't have to check any of these triangles. And the same thing here, like I'm going to be in one of these two. Maybe I'll be in both if my ray hits like, you know, if you have two boxes and you're shooting a ray like this way, for example, you might have to check both of them. But the whole idea here is that you want to not have to check like every single triangle of the mesh for intersection. And that's what we're going to kind of do today. I don't think we'll get there today, but we're at least going to visualize the boxes, and we'll do a way that we can split these boxes along their like maximum dimension. So maybe like we can play this. You can see the box is split there, and then as he increases the depth, they split again and again and again, and then eventually what you want is boxes that kind of look like this, where you're not like splitting it like a slice of bread, but you're splitting it always like along its maximum dimension. And we have 3 dimensions to work with: the X, the Y, and the Z, right? So that's the plan, and I've already created a really simple scene for this that we'll be working off of. All it has is just a basic sphere mesh inside of it. Nodes. Yeah, so this isn't, like, it is 3D, but you can't really tell. You can kind of tell the points here kind of wobble around. Like, I could set the detail of this thing to be kind of low. Like 5 and 5 or something. And you can kind of tell as I, you know, orbit around it or whatever. It is 3D. But I think working with a sphere will help, because a sphere is like symmetrical on all sides. So it would be really easy to tell if the algorithm is working properly. Because in the end, what we should get is kind of like I think they're called like octrees, and where you have 4, well, it depends on how many times you're splitting the bounding boxes. But in our case, we'll have probably 4 on the bottom and 4 on top, which means we split 4 times. You split the main bounding box in half, let's say, and you split those halves in half, and then you split again those halves in half. And in this case, it will be a half, I think, because it's totally symmetrical on all sides. Or at least very close. So let's get started, I guess. I have this file here that we're going to import, and these aren't the best names for these things. We'll just work with it for now. We can always go and change them in the future. But we're going to need the node class. And what I want to keep track of, this is kind of just following along with the video, what he keeps track of. Like he has, shows you the code sections in between the visualizations. So I just kind of just copied these over one by one, but we'll see how much I remember. And I've got it in my notes if I need to refer to it. So a node, we're going to keep track of its bounding box. That'll be a t.bounding box, or box 3 in this case. Let's import t, so t is from 3. 1 second. We're working in WebGPU in this repo. I don't know if we should export it, but we got the bounds, and then we're gonna need to keep the triangles around as well. And that's because when we check for how to split these things, or it's actually how to increase these bounding boxes, we're always gonna split in two. Right here where we do the recursive call. But in this loop over here, like we loop over these triangles, and we want to put the entire triangle into one of the bounding boxes, not like parts of it, or like, you know, one vertex here and the other, or I'm sorry, one vertex over here and the other two in the other box. We want to put all three in the same box. So that brings up a point that this isn't going to be very efficient for multiple reasons, but with such a simple geometry, it'll be easy to understand and easy to test and make sure things are working properly. I think later on in the video, you know, there's a lot of optimization to be had. Yeah, like this, I think. Talks about byte nodes, I guess. That might be like related to like Morton codes and stuff. But we'll keep it really simple in the beginning, and then we'll optimize later. So, you know, turning these things into triangles, we've already kind of got them as triangles. If you know anything about Three.js, you kind of know that the positions attribute of the geometry is either going to be consecutive triangles, or it's going to be indexed, in which case you loop over the index attribute to know like how you're going to be drawing these things. And that's kind of like indirect drawing, I think it's called. I don't remember if this thing is indexed or not, but we can take a quick look. If we take a look at the mesh, we'll just log out mesh.geometry.getIndex. And if this is not null, then that means it is indexed. And usually indexed geometries, they're cheaper to store because you're not storing copies of the same vertex. You only have one, like if you have a triangle, let's say, but well, that's not a good example, but if you're drawing two triangles, and let's say they share some vertices, you're not putting, you know, 1, 2, 3 of the first triangle and 1, 2, 3 of the next triangle. You've only got the two vertices that they share, and then the two that they don't. Maybe I should draw that. But if you're drawing something like this, rather than putting like 1, 2, 3, like rather than having your positions be like this, 2, 3, 4, you can get rid of one of these, and then you can do index drawing, and your index array or attribute might be like draw 0, 1, 2, and then I want you to draw 2, let's see, that's 1, 2, 3. And doing that, if you have, you know, large enough geometry, eventually this will be much more efficient to store. Because you get rid of like all these duplicate positions and stuff that you can just refer to in the index attribute. So it looks like this thing is indexed, which is good, because my notes assume that things are indexed. So this will be a good example to show how you loop through vertex information for a geometry that is indexed. But we'll get there in a moment. Let's go back here. We're going to keep the bounds, we're going to keep the triangles. It'll be an empty array to start out with. And luckily 3 has a triangle class. Oh, this needs to be array. The only really thing we need off of this triangle class is a way to get its center, which is actually pretty simple because it's just a midpoint formula. You know, these triangles live in 3D, right? They're not on a 2D plane or anything, they live in 3D. But let's say, you know, you had... This is the same formula for calculating the midpoint of, like, 2 points on a line or something like that. You know, if you had, like, 4 and 5, you'd add them up and you'd divide by 2. If you had 2 points, like here and one out here, and, you know, this might be, like, 5, 1, and this one might be, like, 1, 5 or something. You'd add up their x component, you add up their y component, and then you divide by 2. In this case, you'd get 6, 6, and divide by 2, and you'd get 3, 3. So somewhere like right here, midpoint, right? And it's the same thing for 3 dimensions. You just do the same thing. You add up the x's, you add up the y's, you add up the z's, and then you divide by 3. So, you know, I don't know if there's a proof that the midpoint is always inside the triangle, but it should be good enough for our case. Yeah, I'm just thinking, like, how would you prove that? I don't know, but I'm sure there is a proof out there for such a thing. This needs to be new. So we'll keep that, and then of course this is a tree, so we need a left child, which is a node or null, meaning that there is no children there, or yeah, and you need a right child. Just like that, and that's the node class. This is like super similar to, or like just like what you do in computer science, like at university, and you learn how to do like binary search trees and stuff. So pretty much the same thing, at least in like defining the data structure. Let's go back to the video. So let's see if I can find, yeah, no, not this one. So, let's see. Yeah, right here. So, we need a way to construct one of these nodes, and we're going to take in a mesh to do that. So, this is the node, like, what do you call this? File. So I don't like to call it like create node or anything. I just call it create, because if you're importing it from node, it's implied that you're creating a node, right? And maybe we should say create from mesh, but there's only going to be one of these. I'll change it to create from mesh if we ever need a way to create a node from something other than a mesh. Taking a mesh here. And the first thing we do is create a node. Node equals new node. We will get this is like the parent, or like the root of the tree. So it should contain all vertices, or all triangles rather. So the way that you do that is you take bounds and you can set from object, and we'll just pass in the mesh there. In the end, we're going to return the node. But now we need to add in the triangles and the children. So in order to do that, to loop over the triangles, we don't really have triangles, we just have like raw buffer attribute data, and we have a position attribute and an index attribute. So we'll need both of those. So let's get those. It's position, default positions dot, or equals mesh.geometry.get attribute. And then it's always, I don't know if it's always position, but like 99% of the time it's under the position attribute. And then we'll need the index as well. That's going to be mesh.geometry.get index. Now this could be null. If it is null, it's not an indexed geometry. But we'll just assume that it is for now. So if it is not, or if it is null, we're just going to exit. We'll just return node. Otherwise, we'll do a bunch of stuff and then we'll return node in the end. So maybe we should do is not equal. And then we'll go into this block here. So the way that you loop over this like index attribute is like this. You have some count. The count is equal to index.count. And then you're going to do I plus equals 3. Oh. Why my formatter not working? Oh, that's why. So when you do I is less than count. There we go. Okay, so this is kind of like saying take every 3, or here I'll draw it out. So our index array, if we take a look at it, we can actually look at it over here. So right here we'll do, yeah, that's what we want. Take a look at the array here. We'll just get the first couple of values. So 0, 6, 7, 1, 7, 8. It's good enough. So these are the numbers in the array, and these are the indices. So what we want is we want to take the first 3 and then the next 3, and then, you know, there's more after this, but we want to take every set of 3. So that's why we increase I by 3 here. Because, you know, in the beginning it'll be 0, and then we jump to 3, and then we'll jump to 6, and then so on. To get the x, y, and z, so to get these numbers here, there's a helper function to do that. You can do index.getX, and you pass in, it's kind of weird because this is index, and the attribute name is index. So maybe we'll call this index attribute. We'll call this index. And then there's one for get y, and then there's one for get z. Now these here, oh, need to make this z. Get y and get z are the same as get x, but internally they add 1. Like for the get y case, it does this, but before it does this, it adds 1 to the index. And then same thing for the z, it does the same thing as get x, but it adds 2 to the index. So this is the x, y, z like indices into the position array. So what we'll need, we're going to turn this into a triangle eventually, but these are just the indices. They're not the actual position, like vertex position of the triangles, or the points. But we can get that if we go into the position array. So triangle, well, t.triangle actually has a method for this. And it's from attributes and indices. The first argument is what attribute we're looking at. In this case, we want the positions, and then we want to get positions, like get x, and that's x. Positions.get y, y, and same thing, positions.get z for z. I think that's right. Let me make sure so we don't have any. We'll have to come back to it. Um, oh, yeah, we don't need to do this. So this is the actual index, where it says like I0, I1, I2. This is kind of weird because, you know, when you create your triangle like this, your vertices don't have to be sequential, right? So this allows you to say, well, I want, you know, the first position in the array, and then somewhere in the middle, and then somewhere, you know, at the end or whatever, right? But we have the indices here. So X, Y, Z. That's correct there. Right. So we have the triangle, and then we just push it into the node.triangles. Again, like, you know, the only reason we're doing this is because triangle has a get center method on it that we're going to use. It would be much more efficient just to maybe like have a view, or maybe like an index to actually the indices here, the index attribute is kind of like a view of the triangles. But I'm not going to worry about like making it efficient right now. That might be a different stream topic. And I don't know if I really like doing streams on those kinds of topics because I feel like it opens the door for, you know, people to say, here's how you should be doing it, you know? Yeah, so we do that. So we have the node for the like root of the tree. We have the bounds set, and then we have the triangle set. Now here we need to do the split. So split node, and then we don't have this function yet, but we'll pass in the node, and that's it for now. We'll take a node, and it has to be node or null because this thing's going to get called recursively, and the null, like when the node is null, that's going to be our stopping condition. That's going to be like there's no more splitting that needs to be done. That's the end of the tree, pretty much. So how do you split a node? Let's look at this again. Make sure we did this right. Yeah, so we pushed in the triangle. That's good. So in order to like better visualize this, well, actually, let's pull up this real quick. Now here's the split function. So this is C sharp, and the reason why is I guess he's doing it in Unity, I think. I don't know, some game engine that, you know, uses C sharp. I think that's Unity. But here's the split function, and it's really easy to convert it to JavaScript, or to TypeScript in this case. But he passed along a depth into this split function, and that's another stopping condition. Well, I guess that is the stopping condition, because you're going to be splitting, you know, however many like depth you want. So if like depth is like 3, you're going to split 3 times, for example. My split, in this case, I'm going to use, you'll see why I'm going to do this in a moment, but we're going to need to visualize these boxes. So one thing that makes sense is that we like create a list of colors. And you know, I could say like depth equals 4 or something, and then just like pick a color whenever this box gets created. But I like the idea of keeping like the depth or whatever tied to the length of this array. So the depth in this case is going to be colors.length. And we'll start out at 0. And we'll say if the depth is less than, or actually greater than or equal to colors.length, that's when we're going to return. Otherwise, we're going to split, and then we're going to call split on node.left and node.right. But this depth variable needs to be incremented by 1. So we'll do depth plus equals 1 before we do that. Oh, and this needs to be, yeah, node or null. Let's see, what does it look like? Oh, and we need to make sure like we don't split on something that like right here, right, left could be null and right could be null, but you know, we haven't done the splitting yet, but you know, if we're in this function here, we're going to assume that I don't know if this is an assumption, but before we do this for each loop here, we will set node.right, and this is, you know, what's happening right here as well. Node.right is a new node, and same thing, node.left is a new node. I guess in this case, you know, we're going to split on a node. We're going to assume that node here is, you can't call split on a null node, right? You can't split nothing. And then we'll do for const triangle of node.triangles. Here's where we're actually going to put these triangles into one of the two children. So we'll say in left. Oops. That's going to be equal to triangle.getCenter.x. But this requires you... Oh, that's right. Yeah, triangle. How can I get... Oh, it's get midpoint. I don't know why it's not called get center, but maybe it's called midpoint because it is the midpoint formula. We're gonna get midpoint, but you need to put this into something. It doesn't like default to nothing. You have to pass in one argument, and that argument is where do you want to store the midpoint. So we'll create a center. We'll put it in the center, and then we'll just grab the x off of that. And we're checking if that's less than the center of the parent's bounding box. You know, the center of the big box, like right now, all we have is, you know, the mesh, and then we have a box around it. This will have some center, and we're going to split along that center, but, you know, some triangles will end up over here, and some triangles end up over here. So if they're on the left side, then its x position, you know, this is, you know, looking down the z-axis, its left position will be less than the center of the bounding box, like the x of the bounding box. You know, if the triangle's center is like this, well, let's see. Where's the undo? Yeah. So if we're looking at like this triangle, right? Its center, and this is a triangle on the mesh. Its center is right here. It needs to go in the left box, and the reason why is because its x position, this is the x-axis here, is, you know, and this might be 0. It doesn't actually have to be 0. It's always going to be less than whatever the bounding box's x position is. We'll put it on the left. But if it's over here, you know, this number, this x or whatever, should be greater than whatever the center is. And then we'll put it on the right. So we need to get the bounding box center, so that's node.bounds.center, actually get center, and we can put it into the same center, because we don't need to, we can like overwrite center there, because all we need right now is just the x off of it. So that will tell us if it needs to go in the left or not. And then we'll do side equals in left. If it is, then it's node.left. Otherwise, it's node.right. So this is, one of the two children. And then we need to move that triangle's points into that bounding box. Side has a bounds as well, but right now it's empty. It's like an empty box. So we need to expand by this triangle that we're considering. We're looping over each triangle here. So we need to expand this bounds by that triangle. So all you have to do here is say dot expand by point, and every triangle has an A, B, and C. Oops. Just like that. And that's it for this part of it. His, grow to include try. This grow to include or whatever it's doing is doing this. So doing this should split, the main parent bounding box into however many colors we have. So if we, drop this down to like 2 colors, and then we do split on this, we won't be able to see it, but we can at least log it out. Take a look at it. I mean, we won't be able to see it in the scene, but we can look at, oh, I don't know. I don't really use AI for anything. I don't even know what OCR is. What are we doing? Oh yeah, we're logging this thing out. Where is it? Here. So we got the mesh. We'll do create mesh, and I don't know if this returns anything, right? This is going to be like a tree, for example. This lives like right here. Oh yeah, I need to export it. Okay, there it goes. So let's see what this returns. Yeah, it returns a node, that's good. So let's log it out. Okay, and we should see, we've got 2 colors in the array at the moment, so we should see 2 splits, right? So that's, this is the first split, and then this is the second split. And we got a left and a right that are null, and then if we look at right here, they should both be null. And then this right is also split twice. And then there's nothing on these left and rights. So it did split twice. And if you take a look at, let's look at this left one, for example. Oh, the triangles are empty. That's not right. Or is, oh yeah, that is right, because these are null. Right? Where's the triangles? Why are they all null? Okay, yeah. Yeah, so the left here has 40 triangles in it. No, I'm sorry. The left here does not have any. This is hard to read. Did I forget to push the triangles? Yeah, I think right here we need to also push the triangles. I forgot to do that. Yep. Oh wait, hold on. Yeah. Okay, I'm not crazy. Now we need to do side.triangles. So these are going to be references to the same triangles, but again, like you might just store the indices or something and then refer to like the root, because the root is going to hold all the triangles. To make this like more space efficient or whatever, you know, maybe you just store the indices of you know, what triangles this side currently has in it. But we're not worried about efficiency yet. So side.triangles.push this triangle. That's better. And then what should happen is there's 40 triangles here. There should be, if we add up the triangles for left and right here, this should equal 40. So there's 16 over here and 24 over here. And if we look at the right, it's left and right should add up to 40 triangles. We got 10 here and you got 14 here, so that's 24. I mean, that's what you'd expect to happen, right? You're just pushing the triangle into one of the two children. But the reason we do that is because when we split again or whatever, those triangles need to be carried along with the node. So you have to like bring the triangles along with you. So yeah, that's good. So this all checks out. And now we need a way to present these things. So this is kind of the hard part, is how do you display these bounding boxes in Three.js? And what I want to do is use a box 3 helper, because we have a box 3 right here on the node. So what I ended up doing is I had, well, I'll just do the code. I got it on the other monitor here, but I'll explain it as we go along. So I called this create groups, or what did I call this? I guess I did call it create groups. It takes in a node, and it takes in a groups array, and a depth. I guess we don't need to log the tree anymore. Okay, so what we do here is we're going to loop over each child and add them into a group, but each node we need to convert into, or like create a bounding box helper out of each node. So the, you know, exit condition, that's going to be depth is less than, I'm sorry, depth is greater than colors.length. Or I guess you could do here, you could do, what would it be? It'd be node equals null. We're just going to return groups. Let's do add groups, because what we're going to do is push a new group, or push to an existing group, or create a new one from here. So we'll just return, like that'll be our exit condition. And you know, if you returned, then all the groups have been added to this array that you passed in. I'm going to make this array mandatory, because, you know, you don't want to add groups to, you know, we're not going to return anything from here. We could, but you're going to add groups to something, right? You need to pass in, because presumably you'd want to capture these groups and do something with them after this function, you know, exits. So let's do our recursive call down here. It's node.left and groups and depth. But before we do that, we need to add 1 to the depth. So depth plus equals 1. So it's going to be really similar to this. You know, we're just kind of looping over the tree. And in that case, you know, you might make like a traverse function or something, and then provide in like a callback function for traversing this thing. But again, that's like another optimization that I'm not going to worry about right now. And you could like traverse over it in different ways, right? You could do like in order traversal, because you know, do you do your like work before the first split, after the second split? Or I mean like before, or do you do it here, or do you do it here? And you get different results in different cases. Okay, but here's where we need to do some work. So we need to do groups dot, or we'll do groups at depth. That might return undefined, so the reason why is that, you know, the depth here could exceed the, you know, there may not be anything at that location. I guess in that case well, I kind of want to carry depth along. We kind of need that, but I don't want you to be able to set the depth. Because if you were able to set the depth here, like at 7 or something, then, you know, the first thing you'd be adding to is position 7 here, which is kind of weird, and you wouldn't be able to loop over it like in a for of loop. So we'll just code it in there for now, because we do want to carry this depth along to the recursive calls, but at the moment it's something that you can set as a parameter, and it shouldn't be. So maybe we do the thing where we do like this. It's like a private function that sets up that state that we're carrying along, and depth equals 0. And then here we'll call, oh wait, I want to keep that. Move this down here, and then we'll do underscore add groups node. Why is groups any? Oh. Node, we're just gonna pass through the arguments. You could do it like this, but TypeScript does not like you to use arguments. Yeah, I think arguments is correct. I don't remember what this is called, but there's always a reference to the parameters that you passed in. Yeah. And I guess it's an object, so you can't spread it. And I don't know if it's only available in functions or also like arrow functions. Yeah, but anyway, it doesn't matter because this is such a simple function, I guess. What is this? Nodes. Or nodes, rather. Yep. I need to make sure I get all these right. Ah. Okay. Yeah, so this could be undefined, and the reason why is because what happens if you try to index into the groups array and you get something out that isn't there, right? If you do, oh, where's the console? You have some array like A, B, C, and then you do, oh, I need to save this. Letters at like 7, that's undefined. And you might say, well, you should know like what indices you're working with, but you'd be surprised that, you know, somehow you've got some weird number in here that, was beyond or beyond the length of the array or something, and now you returned undefined here, and JavaScript just says, yep, I'm going to assume that that's undefined and we're good to go or something, right? So I like to turn on that TypeScript setting that, this could be number, or I guess in this case, group or undefined. And we have to check that we didn't get undefined out. But if it is undefined, in this case, we're not going to do push. We're just going to set it equal to a new group. So this should always return a group now. And the reason we're doing this is because if it's the first thing at that depth, there won't be a group there in the array. But if it's not, then it should return a new group here. Or I'm sorry, not a new one, but an existing one. And we'll just push to the existing one. If it's not there, then we need to create one and push to that. So we get a group out here, and then we need to add, we're going to make a new box 3 helper, pass in the bounds. And here, the color, the second argument to this thing is the color. Oh, I need to say T. Well, that we're going to get from the colors array. So the colors at depth. And if this is undefined, which, this thing allows you to pass undefined through, I'm not going to worry about that. If it is undefined, it'll default to a yellow color. Make sure. Yeah, that's fine. That's fine. But, if you wanted to be kind of like what we're doing here, and you wanted to be very careful about what you were doing, you do something like this, or new color, like yellow. And I want to put yellow in our colors array up here, and actually it's already in there. So maybe we'll do like white right here. Yeah, so that's kind of funny how that works, but let's just do white then. So here we'll do color. We take that box and we'll add it right here. And then what we need to do, oh actually we don't need to save that to anything, we'll just do it like that. And that's it, I think. Adding it like this will give you a reference to that group, but I don't think we need a reference to it for anything. So this we need to export this. If we call this over here in the, did I get rid of it? I guess I did. So we'll do groups equals create groups. Is that exported? I don't remember. Oh, add groups. Maybe we should call it create groups because, no, it should be add groups because you need to pass in the group array. Let me take a quick look. Yeah, I think that makes sense. Like, you could make an API or whatever that says, well, we'll create the array for you. But then we'd have to return it from here. And in that case, like, this thing doesn't return anything. It would have to return groups from here. And, it'd have to return groups from here as well. But you'd have to take this and, like, merge the two groups somehow or whatever. So, I'm not going to worry about all that. Yeah, it's still groups. This should be void, meaning that it's going to modify some existing data. Yeah, there we go. And same thing with this. So here, where we add the groups, pass in the tree. I guess we'll call it node. I don't know, we'll call it root, I guess. And the groups. This doesn't return anything, so groups equals new t.group. Or actually this is an array, so that's an array. T.group array. And now, you know, calling this will add it to the groups. Now we can loop over the groups. So we'll do for const group of groups. We'll just add it to the scene.add group. Now we should see all of them, but we don't. That's never a good sign. Let's take a look at the groups here. Oh, it's empty. Should see something, right? No, no, it's not. Okay, it is empty for some reason. Oh, this should be question mark equals. Yeah, there we go. So, when we're setting that position in the array, right? If we just do this, then we're not setting it, we're just kind of creating a new one. So here is, they're overlapping, but here are the bounding boxes. And I could tell this is wrong because we have white coming through. So here, the depth is actually wrong. I can't remember where. I think it's like here. Okay, yeah, I think that's it. The reason on that is because, I guess you could do this. I don't know, you only want to, like, it's a off by one error, so we either needed to add one or subtract one. So that's kind of all there is to it. But now, like, all the boxes are showing. I kind of only want to show, like, whatever depth you want to view this at. And what that means is we'll hide some of the boxes, or let's add some more colors in here. Oh, that's weird. So a very easy way to do this is to use Three.js layers. In layers, you have to set on the individual mesh. You can't set like a groups layer, from what I can tell. Because objects in that group do not inherit as layer or something like that. And another way you could do this is like changing the visibility of the group. That might be simpler. But then you'd have to kind of like, I mean, you're gonna have to keep track of the previous group either way, whether you're keeping track of its visibility or you're keeping track of enabling or disabling whatever layer it's been assigned to. I'm gonna do this in layers because I think it's a little bit more interesting. And visibility is just like an on-off switch. Is it visible or not? The layers is actually where you can say like, you know, I want this object to only be visible if I'm on layer 1, 3, and 5. And then you can change whatever layer is visible, like whatever layer you're on, or whatever layers are enabled at the camera level. Maybe we should do like a little visualization of that too, because that's not something that comes up very often. But you can put different objects on different layers, and they can be in like more than one layer as well. And you know, then you can change or modify or enable or disable or toggle, different layers whenever you go to render through a certain camera. So it's a little bit more flexible, and I don't know if it's necessarily any more complicated, like performance-wise. The visibility, I think, is very easy to understand, but I think layers is good practice if you've never seen like layers in Three.js before. So that's what we're gonna do. We're gonna do layers, and all you have to do is do box.layers enable. We're gonna do depth +1. The reason here is that everything has the 0, like everything lives on the 0 layer. What's it not like here? I guess we'll do set. Is that what you do? Oh, what happened there? Yeah, set layer number. The number here is the depth +1. Okay, what's the problem? Not really, that's what it's mad about? That's annoying. I think that might be, I just like tried to enable, what do you call it? ESLint, and I think that might be coming from ESLint now. How do I check that? Isn't it, Lua? No, wait. Let's see, I think it is require. What's the name of this thing? I think it's require lint dot. I don't know if I remember this. Okay, yeah, get running. So it is require lint dot get running. It's empty. That's weird. I would expect to see ESLint in there. So I don't know where this error is coming from. But I just noticed it started happening, and I tried to get ESLint working because I was trying to work in Type GPU, which has got a plugin for ESLint for when you're writing like shader. I don't know what they call them, but functions that can either work on the CPU or the GPU. It's kind of the same idea with like TSL, right? It's functions that you run through some kind of like shader generation process, but they're not written in GLSL or Wigzil. You write them in JavaScript. But I don't know if I got it working or not. So I just kind of said whatever. I was spending too much time on it, and it wasn't really that important, I think. But anyway, so you can already tell like the boxes are no longer visible because now they, like if you want to set a layer here, you'd have to set, it's a 32-bit integer, right? So you can read it there. It set membership to layer and remove all membership, remove membership from all other layers. So all we're setting is that you're going to live on the layer depth +1. And the reason that we're not doing depth, because depth could be 0. And everything on the 0 layer, like that's the default. and the mesh itself will be on the 0 layer. So we always want to see the mesh. So we have to put these boxes on something more, I guess, different than the first layer, or like the default layer, which is 0. So in order to see that, you come over here and you need to change the camera's layer. This is different than calling, like set will set all of them. If you want to just toggle one bit, or like enable one of the layers, we're going to enable the first layer. There's, you know, the first bounding box. And then if I enable the second layer, there's the 2 there. Kind of weird because, you know, they overlap quite a lot, but there are 2 boxes here. You know, if we increase the number of segments in the sphere, you can kind of tell there, like there's very clearly like 2 bounding boxes. And then if we go all the way up to layer 4, you know, this is the blue one. This is the last thing in the array. This is the last like split or whatever. It should be, I think, 8 across. And this makes sense too because we're only doing it by the X direction, so it's kind of like slicing it in half. Or not half, sorry, slicing it like a loaf of bread or whatever, only in the X direction. At the end, we'll do the maximum dimension. That's a pretty easy calculation, and I'll explain where that comes from. But what I want to do is change, or give you like a way to like go through these layers, and we'll do it just on a button press. So I have my pane set up here, and all we got to do is we're gonna add a button. What goes in here? Title, increase depth. What else? Oh, I guess we need to do label, not title. Does it need a title? I guess it does. Maybe the title is different than the layer, but there's the increase depth button, but it doesn't do anything. So we'll add a handler, or on-click handler. So if you click it, what we'll do is we will disable the current layer. Or this needs to be let, so let I equals 1. We'll do camera.layers.disable I, and then we'll increment I by 1, and we'll do camera.layers.enable I. So this should let us, you know, go through the layers, but there's a problem, is that I will go beyond the amount of like splits that we've done. So if I hit increase depth here, like none of them will show, and that's because I is at 5. And we've only got 4 colors, or 4 layers, or you can think about it, it's 4 splits that we've done. I guess it's 3 splits, because the first one, if you want to call it a split, is the root of the bounding box, or the bounding like tree or volume hierarchy or whatever. So before we do this enable, we need to actually wrap it back around so that it starts at 1 again. So we'll do I mod groups.length, and then we'll add 1. Now, you know, once it reaches groups.length here, it'll wrap back around to 0, and then we don't want to enable the 0th layer, we want to enable the first layer, because that's layer number 1, that's because the red box lives on layer number 1. So if I did this right, if we go here and we click it again, it should show the red box. And then we're just kind of like, you know, going over each layer. Now, I'm not going to add a decrease depth I'm just going to leave it kind of here. But you can imagine it's sort of the same thing. In that case, you kind of have to check for going below, what is it, below 1? If you're below 1, then you want to wrap back around to the start, or like, you know, groups.length -1, I guess. I don't know, it'd be a little bit of like fiddling with the numbers, and probably like an off by 1 somewhere, or I don't know. But it would be kind of the same logic. So, the last thing to do, this is actually pretty simple. I was expecting this to go on for longer. Last thing to do is to split this such that it's not always along the x. We want to split this so that, you know, it's along its maximum axis. Or dimension, I guess. So we need to jump over to where the splitting happens. And right now we're always just splitting along the x. But what we need to do is find out what axis is the maximum of the triangle and of the bounding box. Not of the triangle, because we just need to find it for the bounding box, the parent's bounding box. And then whatever that ends up being, that's where we'll take the maximum axis. Like here we'll do like get component max, I don't know, I guess we'll call it index. Max, I'm not sure what we'll call it. We'll call it max dimension. And here we'll get center.get component max dimension, but we don't have the max dimension yet. Maybe we'll call it max index. This get component is like these vectors, if you think about them like arrays, they don't extend from array, I don't believe. But get component is exactly the same as like doing, if it was an array, let's say, it would be like vector at 0, that'd be your x. Vector at 1, that'd be your y. And your z. This is kind of doing that. Oops. This part here. But we don't have the max axis, so let's calculate that. I'm sorry, the max index. So the max index, we don't want the actual value at that index, we just want the like position in the array, or in the vertex. Or sorry, in the vector. There's so many terms. There's so many terminology that you have to carefully use. So that would be triangle. I'm sorry, you do it out here. So you need to get the size of the bounds. So we'll do size equals node.bounds dot get size, and we'll put it in the, and we actually could put it in center because we don't really need to use the center for anything. In that case, we call it like, this is just like a scratch vector or a dummy vector. Yeah, so we'll put it in the dummy. Now size holds, you know, the dimensions of the bounds, and we define which of these has the maximum, or which of these is the maximum. So max index equals size.x. If that is greater than the maximum of size.y and size.z. If that's true, then it's the 0, like x corresponds to 0. Otherwise, we check if size.y is greater than size.z. If that's true, then it's the y dimension. Else, it's the z dimension. Oh, what do you do here? It's that, right? Yeah. So the reason that you can't do math.max of like this, you can actually spread this too. The reason you can't do this is that it returns the value at that index. You want the index itself. And it would be silly to do like size.find, you know, whatever this returns. You'd be looping over each and then finding, you know, find index or something. You don't have to do all that. We're only looking at 3 values. Yeah, so that's it, actually, I believe. Let's see how this thing gets split up. So that's, you know, along with Z, I guess? Split again. I don't know which one that was along, but then you split again. You know, it's weird because, okay, yeah, so this doesn't have a split through here, but after we go to blue, you know, there's only 2 blocks on top and then 2 blocks on the bottom. But splitting again, now we have 4 blocks on top and 4 blocks on the bottom. And that's why I wanted to do a sphere geometry, or a sphere mesh, because it should be symmetrical on all sides. You know, barring like floating point errors and stuff like that. But now, let's bring in that, something that's a little bit more interesting. Do a knot geometry and see how that gets split up. Yeah, so this looks like, you know, it's splitting everything into boxes. And there should be, what is it, 8 boxes here, if you counted them. It'd be hard to count them, but, you know, it's usually splitting along the, never along the z-axis, because it's not very wide in the z-axis. It's wider in the x and wider in the y. So that checks out. If we do yeah, let's bring that back. Now I kind of want to see what it looks like if we split an actual like GLTF model. We can do that. So we need to load that thing. I'm gonna steal some code from the other visualizer thing that we made last stream. Some add-ons. Let's do this. Dang it. And we don't have load avocado, do we? Oh, we don't have GLTF loaders, so we go up here, get all this, put it up here. This comes from add-ons. This is an import. Okay, and then we need a way to get that mesh. But when the mesh is actually, its material is lit, so we need to add a light to the scene. We'll do new ambient light. Add that to the scene. After it's done loading, you can just add it to the scene there. Not gonna do this. So we need to find that mesh, and I think I have a get mesh function. Yes, I do. Don't have is mesh. Let's import that. So we'll do get mesh dot then mesh. After we get the mesh, we need to create the root. But this could be null. Or like the mesh here could be null. So if manage is null, we'll just return null. Here we'll just return whatever this is. Create root. We'll call this, or we'll do create root dot then. Let's see. Maybe we should call this create groups. And we'll return groups. And here, yeah, this could be null, so we're good there. Interestingly. And then after we create the groups, dot then, get the groups out. That's when we need to add them to the scene, so we'll do for group, const group of groups. We'll do scene.add group. Okay, didn't load. Check the errors. It's never a good thing when you don't get errors messages. Oh, dang it. Oh, I know why. It's the camera, I bet. So when this thing gets loaded, here we'll do, what do they call it? Fit camera to object, and we'll do camera and the scene.gltf.scene. And then we should set this to a really small number. So this is a very small model. Okay, that looks, oh yeah. And then the last thing, and the only reason I know to do this is because we did it last stream. But we need to take this, put it in here. That means we need to get the, we'll pass in the box here, and it will hold, you know, the center and the size. So if you want to capture those for any reason, which we do, because we want the orbit controls to rotate around the center of this thing. And 0, 0, 0 is right here, but the center is up here. So should we rotate this thing? Probably not. We'll do not here, we'll do return null. Okay, that's a little bit cleaner. Okay, let's see how this thing gets split. Uh-oh. What happened? Oh, dang it. Box is not defined. Where does that happen? Dang it. I put the like tabs on there and I'm not used to it. So hitting this, okay, groups is not defined. Where's groups? Where did that happen? Oh. Oh, that's interesting. So I only want to create these groups. Well, you just move it out here. It's no biggie. Oh, what the heck? I don't think that's right. What happened there? That's crazy. I don't know about that. Like, that one looks correct. That one looks correct. I don't know if that's correct. I don't know why it did a huge box like that. Hmm. Yeah, let's do this. We'll do debugger here. And then that will open up the debugger here. Well, we want to go... Oh, dang it, it's going to keep going until... Okay, so we'll... No, wait, I wanted to stop there. I want to stop when it's blue. And you can kind of watch, like right here, when it changes to blue. So bounds here. Hmm. Depth is 3. Yeah, that makes sense. What was the bounds? Is that the last boundary? No, I can't. Is it? Let's see. Yeah, left and right are null. But it should call it again, right? Yes. But node is null here. Node is null there, okay. I think we go through this 8 times. What are we doing? So pounds, that looks right. I'm expecting, like, if we check this, to see some, for that really big box, to see some values that aren't so small. But these are pretty small, so that checks out. Let's keep going. Small and small again. Ah, there's infinity. So yeah, it should never really be infinity. I'm not sure where that comes from. It happens on the last split, right? Okay, let's see. I don't know if this will work. Probably not. No, we still have the stupid debugger thing there. Oh, dang it. Maybe we should do this. Do all these. How is infinity getting in there? That's the question. Conditional debugging. That's a thing, right? Okay, did we break anywhere here? No. No and no. That's not good. Okay, how about this? We go up here. And we do, that's correct. Okay, what the heck? Okay, no, it's not right. Hmm. Well, you know, when I can't figure it out, it's time to take a break. I never really like to do debugging on stream because to me it's kind of boring. And usually, you know, if it's a more popular streamer with more people in the audience, they can usually spot out, you know, identify what the error is like right away. It's always something that the streamer overlooks. So I think I'll figure this out off stream. I mean, it's working for the most part. It worked on the simple models that we like, the simple mesh primitives that we geometry primitives from 3JS. So I'm happy enough with that. I think I'm going to take a break. Probably go get some water and all that, and then come back to it. But I'm gonna end the stream here. So it is also getting dark too. It's kind of late. It's already 7:30. Um, yeah. So next stream we'll just keep following along with this tutorial. I guess in the next part, I am interested to see how we can get rid of these recursive calls and you know, switch over to a stack-based solution. I think that's what's coming up next. So that's one thing we'll be doing. Looks like we'll talk about how we can traverse the BVH. Um, and you know, wherever there is a, oh, this is cool. Yeah, we can do something like this, where we can actually see what bounding boxes it collided with. I think it's good to do, you know, these visualizations along the way for sanity checks, right? I've always like been of the idea that if you can see it, then it's much easier to confirm whether it's right or wrong. And it's much easier to understand if you have some visual way to convey it. Which is kind of hard in 3D graphics, right? Well, hard because 3D graphics is not an easy topic, but easy in the way that, you know, we are in 3D graphics, so we should have ways to visualize these things. Not as opposed to something like, I don't know, like data science or something, right? Or, you know, like people that do back-end engineering or whatever, right? That's not a very, I mean, you can visualize things, but it doesn't kind of like, you don't have to, I guess. Just, I don't think a lot of people are making visualizations for different things. Anyway, that's what we'll do. Probably Tuesday. And that's like 4 days from now, but I'm gonna give me plenty of time to prepare things. So be on the lookout for that, I guess. I feel like I say the same things every stream, but it is what it is. So, everybody have a good, you know, weekend and 4th of July and all that, if you're in America. If you're not, then have a good weekend, and I hope to see everybody again. Yeah, I'll see you later.